Hi everyone. The topic I chose for this final symposium is exercise, physiology, and aging, and I'm going to be focusing specifically on sarcopenia, its effects, and the influence of exercise on the prevention and progression of sarcopenia in older adults. So let's get right into it. There are numerous physiological changes that occur with aging. They include changes to the musculoskeletal system, the cardiovascular system, the central nervous system, the endocrine system, and pretty much every bodily system of our body. You can see some examples listed here, but in this presentation, I'm going to be focusing specifically on the musculoskeletal system and on sarcopenia and dynapenia, which are all tied together. The Oxford Dictionary describes sarcopenia as the loss of muscle mass as a natural part of the aging process. You can see I highlighted natural part here because I find that's actually pretty questionable. Most of the research shows that it's actually more tied to physical inactivity and sedentary behavior, which we'll talk about more as this goes on. But if you look at this picture on the top, that's a comparison on the left of a healthy young adult's muscle in their femur compared to on the right, you're looking at the same MRI of a much older adult with sarcopenia. So as you look at these, you see the lighter gray area, which is our muscle mass, and the darker gray area, which is going to be mostly fat. So as you see on the right in that older adult, there's a much greater percentage of fat, much less muscle overall, which is kind of the telltale signs of sarcopenia. At the prevalence of sarcopenia by age, starting at age 65, you can see from this bar graph that between the ages of 65 and 69, it's about 6 to 7% prevalence of sarcopenia. But when we get up over the age of 80, when you get over to that far right bar, you see it's almost half of adults over the age of 80 are going to suffer from sarcopenia. Now, the exact numbers may vary based on population and based on the criteria people use to define sarcopenia, because that criteria isn't always consistent from one study to the next. But from all the studies I've looked at, the trajectory is very similar. This specific study was out of Japan, focusing specifically on Japanese adults over the age of 65. So this might vary in the specific numbers from population to population, but trend-wise, this same sort of trend plays out between various populations in people over the ages of 60 to 65. About the prevalence of sarcopenia in older adults, but why do we care about this? Well, as you can see here, there are multiple risks that are related to sarcopenia and dynapenia. I'm not going to go through all of these, you can read them on your own, but the main ones that we worry about are going to be fall risk, osteoporosis, and metabolic dysfunction brought about by increased fat mass. So fall risk and osteoporosis combined are a very big danger for older adults. As you increase that fall risk because of loss of strength and loss of balance, and you combine that with the loss of bone mineral density, you have a recipe for very bad fractures, which could destroy the quality of life of an older person. It could take away their independence. It could take away their ability to do activities of daily living. So these are things we want to greatly avoid if we can. Another major issue is sarcopenic obesity, which is a loss of muscle mass and a concomitant increase in fat mass. What this does is it negatively affects our metabolism. So this leads to just overall negative effects on body composition, but it also leads to risk to metabolic health. You lose insulin sensitivity, so you become more resistant to insulin, and it overall increases your risk of developing type 2 diabetes, which could lead to a whole cascade of other health issues such as cardiovascular and kidney disease. Now that we talked about some of the different implications and the prevalence of sarcopenia and dynapenia, we want to talk about some of the possible physiological mechanisms that have been discovered in the scientific literature. Hallmark of sarcopenia is obviously the loss of muscle mass, and that happens at a rate of 3 to 5% per decade starting at about the age of 40, and that rate actually increases as we get older, closer to our 70s and 80s. So this loss of muscle mass comes from a decrease in the total number of muscle fibers, as well as a decrease in the length and diameter of each muscle fiber. So as that fascicle length decreases, that means you have fewer sarcomeres in series, and that means you're able to produce less muscle force, and the shortening velocity slows down, which means a lack of power, which is what kind of leads to this increased likelihood of falls, not being able to react as quickly. Loss of muscle fiber numbers is similar between type 1 and type 2. However, the narrowing and loss of size is much more pronounced in type 2 fibers, which also explains this loss of power. Of this loss of muscle mass as we get older is going to be reduced muscle protein synthesis. Now, baseline levels of muscle protein synthesis are very similar between younger and older people. However, after a meal, after eating, younger people experience a large spike in muscle protein synthesis that we don't see to the same extent in older people. This is likely due to insulin resistance, reduced sex hormones such as testosterone and estrogen, reduced growth hormone and IGF-1, and reduced functionality of satellite cells, which are essentially like stem cells that help to rebuild different tissues in the body. In this case, it would be muscle tissue. Loss of muscle mass only accounts for about 10% of the loss of strength in older adults, and that neuromuscular changes are more likely to be the major cause of loss of strength. In older adults, we see a reduction in the number of total motor units, as well as we see muscle fibers not being fully innervated, so the nervous system is not acting as efficiently as it once did, causing a decrease in total overall strength. Ways to prevent and even reverse sarcopenia. Most studies have found that the main risk factors for sarcopenia are lack of exercise and a sedentary lifestyle. So it's been found that strength training can help prevent as well as reverse sarcopenia. Aerobic training is also going to be important because it's going to improve metabolic regulation, so it improves insulin sensitivity and also helps improve mitochondrial function, which has been shown to decrease in older age. Another thing to consider with training is going to be working on improving balance to reduce the risk of falls and the overall risk of fractures. Exciting frontiers of research in regards to sarcopenia is going to be exosome therapy. It seems to like it may be possibly a promising treatment for sarcopenia. That being said, it's still in the very early stages of being studied, so I'd like to see how that's going to play out over time. With that being said, guys, we'll wrap this up. And please, if you have any questions, please post them in the discussion board. I've done tons of research on this, but I've been trying to keep this presentation nice and short and respect everyone's time. So if there's any questions that I didn't answer, please post them below and I'd be happy to answer them for you. Thanks a lot.